So we start off here. Its tangent is touching a one spot. Great, right there. We'll call that point P. All right. Given a curve with a line tangent at a given point on the curve, here's the problem. Find the slope of the tangent line. Somebody tell me, why is that difficult? This is difficult because we only have one point. Slope requires how many points? 2 points. So you can see our challenge, right? So hot in here. So how in the world do we do that? And in calculus, that's the first part of calculus. Two parts of calculus you'll cover this year: differential calculus and integral calculus. This is the chief idea behind differential calculus. Tangent line at one point, find the slope. In order to investigate that, we are going to actually look at an example problem. Given the function f of x is x squared plus 1, find the equation for the line tangent at the point 1, 2. So here we go. I'm going to draw the curve. X squared plus 1 makes what shape? I just drew it for you. Parabola goes up. Okay. And I'm going to move it over a little bit just so it looks a little bit better. And at 1, it has a y value of 2. Very good. And we'll call that point P. And we have a line running tangent at point P. Great. We want to find the slope of that line. Now, I'm going to show you a way today that we can figure that out. It's not the easy way, but it brings up an idea that we need to talk about in calculus in order to make calculus work. So, instead of finding the slope of that line right now, I'm going to create a second line. What's the y value at 2? 5. 2 squared is 4 plus 1 is 5. Okay? So here we have it. Can't see? Broad shoulders. Got it. So this secondary line passes through point P, but I'm also going to say it passes through another point called point Q. And this is not a tangent line. The red line's a tangent line. This is what we call a secant line. A secant line passes through 2 points on a curve, not just one. Well, can we find the slope of the secant line? Will the slope of the secant line in this situation be greater than the slope of the tangent line or less than the slope of the tangent line? Greater than. That's quite obvious, right? So in order to find slope, I need 2 points. Well, point P has a coordinate 1, 2. Wow. What does the color scheme has been changed? Thank you. All right, great. Q has coordinate 2, what? 2, 5. So therefore, in order to calculate the slope, I will take y sub 2, which is 5, minus y sub 1, which is 2, divided by x sub 2, which is 2, minus x sub 1, which is 1. And I get 3 over 1, or 3. Would you all agree that that's a very poor estimation of the slope of the tangent line? What could you do in order to get a better estimation of the slope of the tangent line? Make what smaller? The gap. So I take Q and slide it closer to P, correct? So as we take Q and slide it closer to P, say 1.5, we'll probably get a better estimation, won't we? Right now, I want you to try to figure out what the slope is if we move Q to 1.5 and then to 1.1, 1.01, and 1.001. Go ahead, use your calculator, work with your partners, and see if you can come up with that estimation. Go. Okay, what do we got? What do we got? What do we got? What do we got for the second one? Slope, 2.1. How about the third one? 2.01. And the fourth one? Yeah. So the question is I mean, we're sliding Q infinitely close to P. We've moved Q so that it's within 1/1000th of a unit from P. That's pretty close, right? So what do you think then the exact slope of the tangent line is? 2. I would say that 2 would be a nice guess for what the exact slope of that tangent line is. Now, the fact is that we don't know that for sure. All we can do is look at the data that we have and see where it leads us. And right now, it looks like this is converging towards 2. All right? But, again, the beginning problem was write an equation for the tangent line. In order to write an equation, what two things do I need? Slope and point on the line. What's the slope in this situation? What's the point on the line? 1, 2. So I break out my y minus y1 equals m times x minus x1. And I've got y minus 2 is equal to 2 times x minus 1. On the AP Calculus exam, you may leave the answer like that. That's an equation for a line right there. In this class, you may not leave it like that. You must then put it in slope-intercept form. Y minus 2 is equal to 2x minus 2. So y is equal to 2x. This is the line that is tangent to the curve at that given point. Now, I want you to understand how interesting this truly is, because if I would have asked you at the beginning of the day to try to come up with a line that is tangent at that given point, you would have spent a long, long time trying to figure that out, okay? Well, we can do it pretty quick. You just saw what we came up with. If I go into my calculator and I type in x squared plus 1, and I also type in 2x, watch what happens here when I graph it. Tangent. Pretty cool. Okay. Zoom. You Is that right? Get out of here. 11:15. We'll start when you get back. Hustle back. Yes. So what is this? Okay, let's go. So you have point Q. We picked an arbitrary number. Picked 4 or 3 or 2.5 or 1. So what we do is we use x to represent that we picked an x value. And then what did we do with x in order to get the y value? We plugged it in, and so we got x squared plus 1. So that happened to be our y value. So whatever the function is your y value, and x was your x value. So you can see that we have y sub 2 is x squared plus 1 minus y sub 1 is 2 over x sub 2 minus x sub 1. And we get 2. In plain terms, what does this mean? As q approaches p, that's what that means. As q approaches p, the slope of the secant line goes through 2 points, right? The slope of the secant line, the 2.1, approaches the slope of the tangent line. Which is equal to 2. Do you get that idea? But you write it down and then we'll move on. But we'll make sure as we slide Q towards P, the slope of the secant line will approach the slope of the tangent line. It's actually on your test. Your next test, you have to say that exact thing. As Q moves closer to the slope of the secant line approaches slope of the tangent line. And so what we do in order to show that notation, this idea of approaches, limit is the terminology we use. So starting Monday, we're going to teach you all about limits. And limits is kind of the final piece that was used to really make calculus, I guess, something that you could write down in strong terms and use. So once the concept and theory of limits was developed, calculus exploded from there. So let's try an example that you'll have in your book today. Okay, the point P, 3, 2, lies on a curve y equals x plus 1. So if P is equal to 3, 2, what would point Q be equal to? What do we choose for the x value? We choose x. What's the y value? Square root of x plus 1. So you can see right here it says, if Q is the point, x, square root of x plus 1, that just means you take whatever you want for x, and then to get y, you plug it into square root of x plus 1. Okay? Use your calculator to find the slope of the secant line. PQ correct to 6 decimal places. We'll just go to 3 for today. Okay? For the following values. So here's what I would like. I would like everybody to start with x equals 4. And then I would like you two and you two to do 2.5. Like everybody in the middle to do 2.999. And I'd like you guys to do 3.0001. Okay? So see if you can come up with the slope of the secant line. Everybody do 4. And then you guys could check together. If you need help, raise your hand. But you should come up with the slope. Again, you need 2 points. You've already got 1. You got 3, 2 is 1 point. The other point is going to be 4 something. You got to come up with that something and find your slope. Watch. This is x. How do you get y? Plug it in. So it's square root of 5. Yes, I will open the door. Yep, it's getting hot in here again. Okay, let's come together. We'll do one of these together as well. What did you get for 4? What did you get for slope? 0.236. And 2.5 people. What did you get, Miss Hannah? Okay, how about the 3.0001 people? 0.2 what? Okay, so we'll try the 2.9991. So you'd have the square root of 3.999, right? Minus y sub 2 is 2 divided by 3 minus, I'm sorry, 2.999 minus 3, correct? So again, you could just use your calculator here, and if you go square root of 3.999, enter, then subtract 2, and then divide it by negative 0.0001, right? Whoop, should be another 0, right? Right? Try one more time. Second, square root of 3.999. So Mercedes, did you get 3.99? Okay, minus 2. Then divided by, I'll put parentheses around it, 2.999 minus 3. I get 0.25002. 0.25002. Okay? All we're doing is finding slope. We're just using decimals. You got to be ready to work with kind of weird numbers. Okay? So, if you look at this, it says, using the results of part A, guess the value of the slope of the line tangent to the curve at 3, 2. What do you guess is the slope? Look at our values. 0.236, 0.2583, 0.25002, 0.250. What do you think the slope is? 1/4, sure. Yep, great guess. That's what we're going to use. You can see that 4 is not all that close to the curve at 3. 2.999 and 3.0001, those are very, very close. Using the slope from part B, find an equation of the line tangent to the curve at 3, 2. Again, in order to find an equation for a line, what two things do you need? Slope and a point on the line. What's the point on the line? 3, 2. What's the slope? 1/4. So y minus y1 is equal to m times x minus x1. Put it into slope-intercept form. Y minus 2 is equal to 1/4 x minus 3/4. What do I do to both sides? Add 2, and 8/4 added to negative 3/4 will give you 5/4. That is the equation for a line tangent. Did anybody make a mistake when they were typing these numbers in? Raise your hand if you made a mistake. I did. Just 3 of us, 4 of us, 5 of us. Can I show you how to avoid a mistake? Now, on your assignment, you can either type them all in like we just did, or you can use your calculator to do it a lot more efficiently and effectively. Ready to see the other way? You can write a slope function. Instead of typing in these numbers, I'm going to use P is equal to 3, 2, and Q is equal to, like we said, x and square root of x plus 1. Let's write a slope function. What's y sub 2, given this is P and that's Q? What's y sub 2? Square root of x plus 1 minus, what's y sub 1? 2 divided by x minus 3. That's my slope function. I'm going to type that in to my calculator. Y equals. Okay, so if you go into mode, you're probably working in parametric. Move over to function and you'll be out of it. So within my y equals, I have parentheses. We're going to do square root of x plus 1 minus 2. That's the numerator. And then I will divide it by the denominator, x minus 3. So I just wrote a slope function. Where is that function undefined? At 3, because you would be just doing it at 1 point, and that seems impossible. Now that I have my slope function written, I can go into my table And now that I'm in my table, oh, and for those of you who maybe don't have this set up right now, again, you go table set, and the independent variable needs to be set to ask. The dependent variable needs to be set to automatic. And once you are sitting there, you can then go to your table, and instead of trying to figure out that the y value is the square root of 5, I just type in 4. If x is 4, this y value is not, it's not this y value here. It's the slope. I wrote a slope function, 0.236. See it? And then I type in 2.5, and I get 0.2583, 4. And I type in 2.999, 9. And I get 0.25002. I type in 3.0001. I get 0.25. You get those values. So instead of doing it over and over and over again, you can write a slope function just like we did and generate the values that way. Okay. Now, what's going to, yes, question. I will. What happens if I, you could, if you're not convinced that the slope is 0.25, go ahead and type in a number that's even closer. 3 point, a lot of zeros and a 1. And 0.25. You can draw yourself closer, infinitely small, to see what it is. What's going to happen if I type in 3? There. That's the only spot where the function isn't defined. You've got a hole there, okay? You can't draw a graph through that spot. It's a problem, okay? But everything else you can. So today, what I want you to work on is right here. Section 2.1, you can write this at the front if you want. That's why I leave that spot for assignments right at the front. Section 2.1, page 69. Do problem 4 first, because 4, you won't be as likely to make a mistake. And then do problem 3. Careful how you plug everything in there. There they give you y is equal to x over 1 plus x. So that means that point Q looks like that. A lot of people mess this up when they plug it into your calculator. But we should be able to work through that. We're in AP Calculus. We need to be able to plug in functions properly. So if you're not getting the right answer, you probably plugged something incorrectly into your calculator. You're going to be doing exactly what we did right now. I was going to run copies of the book pages for you, but the copier ran out of toner today. So normally I would hand out your book page so you could start working on it. I don't have that. But I do have a few books where you could take a picture so you could start working the rest of the day, or grab your book later on and work through it. Okay? Just these 2 problems. Tomorrow, seniors have an advisory during second hour, so I don't have second hour calculus. But I told them they need to watch video because we are going to finish up the section 1 notes. We'll be trying a word problem tomorrow. Tomorrow you guys will have a very light assignment in class because the rest of the group, they're going to have to watch the video to get the assignment because they don't have class. I don't know. I have no idea. All I know is you got an assembly. What's that? You go to second hour, or you go to first hour, and then my guess is you'll report second hour, and a voice will come over the intercom and say, report now to the... I have no idea. You think it's pictures? Oh, okay, cool. All right. Okay. Anything else you guys need from me before I stop this? Going once, going twice, 3 times.